Greetings everybody and welcome to Euclid's Proposition 11. What we're given in this proposition is a straight line and we're given a point on the line. And what we're asked to do then is to construct a line perpendicular to our given line that passes through our given point. So let's take a look and see what the proof of this proposition would look like. What we do to begin is to choose any other point D which is on the line AB. And so if we choose our point D, now by one of our postulates we can draw a circle centered at C and passing through our point D. Now that circle gives us a point of intersection with our line AB at our point E. Now because E and D are on the circle centered at C, it means that our line segment EC is going to be congruent to our line segment CD. Now that we are done with our first circle, let's take him out of the figure. And what we now want to do is to draw two other circles, which we can do by postulate 3, that we can draw a circle centered at E and passing through D, and we can draw a circle centered at D and passing through E. Now what that gives us is a point of intersection at F of those two circles. Now this should be familiar from Proposition 1, where we've really constructed an equilateral triangle, E, F, and D. So in particular, it means that our line segments EF is going to be congruent to our line segment DF. At this point, we're finished with our two circles, so let's take those out of the figure. We don't need them anymore. And we can put in our line segment between F and C. Now what we have is two triangles. We have our triangle ECF, and we've got our triangle DCF. So from what we've outlined here, we can see that those two triangles are going to be congruent by our side-side-side congruence property. Now in particular, what this means is that our angles between sides 1 and 3 of our triangles will be congruent. And so my angle FCE is going to be congruent to my angle DCF. Now because FCE and DCF, if we put those together, we really get a straight angle ECD. Then that means that our two angles, FCE and DCF, will be right angles. And so taking everything else out of our picture, if we just look at our line CF, it means that because those are right angles, that we've drawn a line passing through C, which is perpendicular to our given line AB, as was to be demonstrated. Hope you guys have enjoyed this, and I will see you in the next proposition. Take care.